Good evening, everyone, and welcome to this AHDB webinar covering how best to manage in-calf cows to promote calf health, welfare and performance, which is very topical as we start to head into the winter months. So my name is Sarah Pick and I work in the Beef and Lamb Knowledge Exchange team at AHDB. And I'm delighted to be joined by our speaker for this evening, Kenny Rutherford, a scientist from SRUC. So this webinar, along with others focusing on suckler production, has been brought to you as part of the AHDB Maternal Matters campaign. The Maternal Matters campaign aims to highlight the importance of cow performance in the suckle herd, providing suckler producers like yourself with the tools and the knowledge to be able to improve maternal performance in the herd. And we're particularly focusing on two aspects, so they're improving herd fertility and reducing age at first calving. So we've created a website as well as hosting a number of webinars such as this one and also podcasts. We also have regular articles in Farmers Weekly, so please do look out for those. For further information, please visit the website, which is ahdb.org.uk/maternal-matters. So the webinar this evening is going to focus on something called fetal programming, which is basically when environmental factors during pregnancy, including things like stress or nutrition, impact how the calf develops and inevitably its lifetime performance, which I find utterly fascinating. So the plan is I am shortly going to hand over to Kenny, who will present for around 30 minutes, and then there will be a chance for you to ask questions at the end. To ask questions, you need to type your question into the question box, which is on the right hand side of your screen on the toolbar. And of course, remember to press send. I will then read out all of your questions at the end of Kenny's presentation. So please make sure you keep sending those in. So without further ado, I'm now going to hand over to Kenny. So Kenny has worked in the animal behaviour and welfare team at SRUC for the past 20 years, and his main research interests are in early life development. Kenny is also a key supporter of the AHDB Maternal Matters campaign, which we are really grateful for. So over to you, Kenny.
Great, thank you very much, Sarah. So, yeah, good evening, everyone. It's really great to have an opportunity to speak to you tonight. So, what I'm going to try to do tonight is give you some information on an area of research I've been involved in at SRUC for a number of years now. As Sarah's already introduced to you, this is investigating how the experiences of pregnant animals causes changes in their offspring. So we've been working in this area for about 10 years or so, initially actually in pigs, but more recently in sheep and cattle, doing some research studies at our own experimental facilities and also working on commercial farms. Tonight I'll really just be focusing about some of this area in relation to cattle. So I suppose I want to start perhaps not in the obvious place, which would be at the beginning, but rather to leap straight to the end and give you some advanced sight of what conclusions I plan to draw at the end of the talk. So firstly, I guess, as we've already heard, the simple fact that things that happen to pregnant animals affect their developing fetal offspring. And secondly, that these effects can change progeny biology before birth in ways that matter for the rest of the animal's life. So I'll say a little bit about some of the broad background to this area of science and also a little bit about how and perhaps when these effects occur. My third conclusion is that for farm animals, these early experiences effects can mean alterations in various things that are relevant from a farm perspective: productivity, traits involving animal health or animal welfare. Finally, and I guess what's the ultimate takeaway message from tonight would be that there are opportunities to improve farm management during pregnancy by thinking about these sorts of things which might give some avenues to improve farm performance. So I'll finish up by mentioning some approaches that could be taken to thinking about what this all means for your unit. So I guess moving on to the first point, so I'm going to start here by telling you something that hopefully you all already know. Mothers are important. The basic message of tonight's talk is that this is particularly the case during pregnancy. And again, this is something that we all will know pretty readily from our own lives. Stories relating to current medical advice for women during pregnancy are common in the media, so you can see here. And any of you that have been pregnant or had someone in your life be pregnant will know that paying attention to healthy consumption of different substances, avoiding stress, maintaining good health are key parts of recommendations that are issued to women during pregnancy. So really the message tonight is going to be about how we translate all this information that we probably all know already from that context into the context of animal management. I am going to start though a little bit by just giving you some of the background to some of the human work that really triggered a lot of interest in this. So it's an area of science that's sort of unique in some respects in that it started with a lot of studies in humans, and that has latterly translated to animal research. Often in science, things are the other way around. So some of the really early critical studies that were important for this, such as the one you can see here. So this is the Dutch hunger winter cohort study that has been really influential in thinking about maternal nutrition. So this is a pretty extreme example of the importance of nutrition. It comes from periods where in the Netherlands during the Second World War, various people, including some which were pregnant women, were exposed to periods of quite intense starvation. And researchers have since then been able to track the offspring of those women. Some of them are those that still survive are in very elderly periods of their life now, but those offspring have been seen to have higher levels of various health disorders, physical and mental health disorders throughout their life compared to people born during the same period whose mothers were eating normally. Sarah also mentioned stress, and one of the relevant, really interesting studies, more recent studies that have come out in this area, again in the sort of human medical sphere, from something called Project Ice Storm, which has been tracking outcomes in children born to mothers who experience periods of stress as a result of a really severe ice storm that hit parts of eastern Canada, northeastern America in the late 90s. So children born to these mothers are seen to have higher levels of various behavioural disorders at school, other signs of altered development compared to comparable women who were in the same area around the same time but were not didn't experience this severe sort of isolated acute stressful event. So from studies like this, from a whole host of other research studies in humans and then laterally in animals, it's become pretty clear that things that happen in early life can result in long-lasting changes to biology. In particular, we see that these sorts of challenges during pregnancy particularly make offspring less able to cope with various often naturally occurring challenges that occur in their own life. And in more recent years, we've started to turn our attention to the relevance of similar processes for animals, and particularly for animals in a farming context. So just briefly, obviously, one of the pertinent things about the pregnancy period is that developing offspring is sensitive to challenges. But for animals in a farming context, it's also worth pointing out that the period before birth can be a large proportion of the whole lifetime of the individual. So thinking about a beef calf destined for slaughter, about a third of its life is that prenatal period, i.e. the period before birth, that we're interested in these sorts of studies. So I want to move on a little bit to just giving you some of the background of the science that's underlying these sorts of effects before I move on to giving you some more concrete examples. So research work in this area focuses both on what sorts of effects are seen and also on understanding mechanisms of how they occur. I'm not really going to go into the details at all about the mechanistic side of things tonight. But in terms of stress, so we might think of stress as any form of environmental disturbance that animals might perceive of consciously or unconsciously as being in some way threatening to their body or to their continuing and maintenance of their sort of physiology. So when this occurs, there's a well-known cascade of hormones, including the release of cortisol. You might have heard of this, one of the major sort of stress hormones that is present in humans and also present in other mammals and other types of creatures as well. So the cortisol circulates in response to these sorts of challenges, circulates around the bloodstream, making various changes to the animal's biology that are aimed to help it deal with whatever the challenges that it's facing. But of course, the maternal blood supply is connected to the developing fetal blood supply. So when these stress hormones are elevated in the mother, they inevitably quickly become elevated in the developing fetal offspring. And this extra exposure of the fetus to these circulating stress hormones includes changes the fetus in various ways, including very fundamental changes to the way that DNA is expressed in that individual. Similarly for maternal nutrition, so it's obviously the case that the only source of nutrients for the fetus is the mother. So abnormal variations in basic facets of nutrition such as energy or protein supply, or more subtle changes in various micronutrients, these have a direct impact on the development of the calf. And finally, maternal health. So maternal health can impact on the fetus in the same ways and by the same pathways as stress and nutrition. So for instance, many health disorders cause increases in those same stress hormones, or in fact cause altered nutrition profiles in the mother. But maternal health status can also affect the link between the mother and the fetus in various ways, such as altering blood flow supply to the placenta, or indeed altering placental function itself in different ways. So all of these different factors, experiences, events that happen for the pregnant female are being transmitted directly by that link between the mother and the fetus to the fetus, and are causing these sorts of changes that I'll be talking about through the rest of the talk. So this is actually an area where we now know a fair bit about the sort of processes that might be happening. The paper I've highlighted here just was one we were involved in a few years ago, which was also actually funded by AHDB to really collate all of the evidence that was available at that time. And the book that I've highlighted here on the right is from some researchers in Australia who have been very interested in this topic, particularly in beef, in relation to beef and sheep production. So we now think we know a fair bit about what's happening in relation to that link between the mother and the fetus. What's perhaps a little less clear and still a developing area here is what this the prevalence of this when it comes to actually on-farm changes. But all of that science and all of that, the studies that have been conducted, the reviews that have been done, have really highlighted the fact that we know that many areas of biology which are important from a farm production perspective are open to change depending on what happens during the period before birth. So I've listed a number of these here. All of the examples I've included around the sort of circle here. There are examples where these sort of early life fetal programming effects have altered outcomes in progeny, sometimes in cattle, sometimes in other species. So really the key message here is the way that production stock turn out depends not just on genetics, but on all these important early life effects. Indeed, there's even some evidence that animals with high genetic merit for performance are more susceptible to these deviations from normal development compared to less highly selected individuals. So I want to move on now to some examples, particularly to the sorts of outcomes that might be seen and how relevant these might be from a farm perspective. So the first thing to say, I guess, is that in extreme cases, of course, these effects are highly relevant and highly obvious. So the example I've included here is congenital chondrodystrophy. So this is a severe malformation of limbs seen in calves. It's been linked with various aspects of maternal nutrition. Still some debate, I think, about the exact causation of it. But in epidemiological studies, such as the one that I've included on the right here, is very clearly seen to be linked in terms of prevalence with periods of drought during key points of the pregnancy in the mother. So these are studies from Australia, where obviously periods of drought are much more common. But of course, most of the changes we see in semi-normal circumstances, if we can call them that, are not this obvious or this extreme. So most of the individual changes might be relatively subtle. It might be some percentage reduction in weight or growth, or alterations in temperament or disease susceptibility, that on an individual farm level might be very difficult to pinpoint in terms of causality. So this is because these things are inevitably separated in time between the event that happens to the mother and the outcome for the progeny sometime later in its life. But they might also be separated in space in terms of management within the unit, or even more so if animals are being sold to other farms, perhaps even quite far afield. So actually on an individual farm level, identifying that this link is occurring is relatively difficult, which is why we try and take this into research context and do some controlled studies where we can better understand what's going on. So the examples I'm going to include tonight in terms of cattle, I'll start with some of our own recent work looking at nutrition, particularly looking at the impact of body condition in pregnant suckler cows. I'll say a little bit about an example of maternal stress and the sorts of effects it can have, another example of maternal health and those sorts of prenatal impacts, and finally I'll talk a little bit about the example of heat stress. So I'm sure I don't have to tell you all that much about the use of body condition scoring as an easy management tool to assess fat reserves in individual cows. Advice and information about body condition scoring has been out in the farming industry, particularly for cattle farmers, for many, many decades. But there is a key question, I think, about how successfully body condition is managed in UK beef herds and what the consequences for that are for head performance and welfare. So this has been a focus of some of our work at SRUC over the last 5 years or so. So the data I'm showing here are from a large-scale study of commercial beef units in Scotland and England that we conducted probably 3 or 4 years ago now. So for this study, we visited these various units, recorded body condition score for the whole herd in the autumn and in the spring. For research purposes, we can accurately score condition down to quarter points, but for the purposes of management, probably thinking about these in these 3 zones of lean, good and fat is as accurate as you need to be. So here we say we categorize a cow as being lean if her condition score is less than 2.5 on the normal 5-point scale, and as fat if she's above 3.5. So you can see here across these roughly 5,000 spring calving cows that we scored, we found that about 1 in 5 cows were in lean condition, i.e. below the target for that period. And many farms had more than that, going right up to one farm that had over 2/3 of their cows lean. So we also looked at how body condition changes from autumn to spring. So here from left to right, we have the autumn condition score, and then the blue bars up or down from that are changes in that between autumn and spring. So you can see that cows which were lean in the autumn are fed to increase condition, and on the right-hand side, cows that were fat in the autumn are fed to reduce condition. And the cutoff is around the optimal target for pre-calving cows. So on one level, you'll see that actually the management advice and the industry recommendations that are out there about modifying condition score are being followed to some extent. But you'll also see that the increases and decreases here are not symmetrical. So there's more loss of condition than there is gain of condition in different areas. And the net effect of all this is that actually while the proportion of fat cows decreases and the proportion of good condition cows increases between autumn and spring, the overall proportion of lean cows actually increases from autumn to spring. So one of the key questions then is, what are the consequences of this if we think about it from an early experience fetal programming perspective? So we can see that there's a fair amount of suboptimal management of body condition score within the industry. And obviously there are some impacts of that we might expect that are pretty well known. For instance, effects on fertility that are just about the cow. You know, much poorer fertility being seen in lean cows that are known to be lean through the previous winter. But these research studies we did also manage to track some of the calves born to large proportions of these original condition scored cows. So we had calves, we had information on various aspects of calf growth, welfare, health, and that we were able to link back to the status of that individual calf's mother over the winter. So we wanted to see what the early life effects of having a mother that's too lean or loses too much condition were. So from those data, we estimated that a calf born to a lean cow has a reduced level of vigour at birth, particularly if that cow has lost a lot of condition on our pathway to ending up lean in the period immediately before calving. And that ties in quite well with work from Rachel Bragg at the vet school here in Edinburgh, which showed that calving really doesn't on average go so well for those lean cows. There's a substantial increase in risk of calving difficulty in those animals. In addition, we also found that calves born to cows that lose a lot of condition are smaller at birth and grow more slowly. So taking all these factors into account, our estimate of the combined impact of that was that calves born to lean cows take about 43 days longer to reach sale weight. So as I noted earlier, in a full herd context, it might be quite hard to link, say, 20% of calves having that longer pre-slaughter period, linking that back to the state of their individual mothers during pregnancy. But it's still something that could be having quite a significant impact on a number of aspects of herd performance, not least economic. So with that in mind, one of the other things we've done with these data is conduct some economic modelling. So you can see the outcome of that modelling here. I'm not, again, going to go into the fine detail of it. Our SRUC colleague, Faisal Akechi, looked at 4 different scenarios, which are the ones you can see here. So these different scenarios are obviously to deal with a lean cow in terms of shifting her from lean to a better body condition score. There are some different ways that could be achieved. We modelled 2 main ones, which is either early weaning and reallocation of silage, or normal weaning and some supplementary feeding to provide the nutritional requirements to bring her up to that good zone. So obviously those 2 strategies have some different cost implications. I also mentioned that the calves that are taking longer to reach slaughter weight as a result of being born to lean cows. What we don't know about that really is whether those, that's because those calves are eating at the same level as calves born to good condition mothers but are simply less efficient, or simply that they eat less than those calves born to good condition score cows. And again, there are different cost implications of those 2 things. So the 4 scenarios here are the combinations of those different things. The basic message is, so I'm not going to get into the profiles of the different scenarios. The basic message here is that it always pays off to mitigate that low condition. So the range of possible per cow benefits is between £45 per cow to £110 per cow, with the average benefit being between about 65 and 85 pounds. So this is an example where, and this is all before we start to think about some of the cow level things that might also be have some financial impact, such as fertility. So the modelling here, the economics of it doesn't include fertility effects for the cow. This is entirely about that relationship between what happens to the cow during her pregnancy and the consequences for the calf. So this, I think, is a sort of clear example where we might see some benefits to various aspects of farm performance by attending to what's happening to the pregnant animal. Before I move on and talk about the other things, so talking here a little bit about nutrition, I did just want to mention that this issue may not be entirely about just what is being fed, but also the way that cows are being fed. So a few years ago, we also did some on-farm welfare assessment work on beef units as part of a DEFRA project. During those visits, we did some detailed behavioural observations for cows in the 1 hour after feed was freshly provided in the morning. So the data you see here are one result of that. Again, the details of this don't matter too much. I'm not going to go into it in too much depth. But the measures you can see here are two behavioural outcomes you can record on a sort of group or herd level. So along the bottom from left to right, we have the proportion of free joins. So this is the proportion of times that a cow joins the feed face during that period that she can do so without having to push another cow out of the way. And on the up and down axis, we have the reverse, the proportion of times in a farm that when a cow leaves the feed face, she does so voluntarily, i.e. without being forced out. So very simply then, on the top right of this diagram are farms where cows can feed almost entirely free of this social aggression. They can come and go from the feed face during that key period when fresh feed is available as they want. Whereas in the bottom left are farms where cows basically cannot access the feed face without fighting for that access. And almost always when they leave the feed face, they've been forced away. We've then in the diagram here just categorized these roughly into thirds based on the combination of these two measures. But I think really the key thing is that on a large number of the farms that we visited, there was some element of this sort of constriction of feeding during this period. Now, of course, cows may, those subordinate cows or cows that are losing out during this period may return to feed later, but there's still also a substantial amount of aggressive interactions occurring during this period, where there's a substantial chance that this is another aspect that could be stressful for these animals. They're literally having to fight to gain access to the nutrition that's being provided to them. So I think this is another aspect where it's worth reviewing the setup on your unit, whether that could be altered to avoid the possible stress of this happening. So I'm going to move on now and just talk about some other examples, just go through these a bit more quickly. So I wanted to turn to the issue of maternal stress. We've mentioned that a couple of times already. I've picked a particular example here just because there's a number of really nice clear studies that have been conducted in the US on this issue. So in these studies, they use a fairly artificial model. They use transportation of pregnant cattle to induce a stress state. Now, of course, some cows may be transported during pregnancy, but overall it's relatively rare. But the researchers use this as a model of a sort of way of generating very clear and time-limited stress states for the animals involved. So in this case, they transport cows for about 2 hours on 5 occasions over pregnancy. But the outcomes of this relatively low number of fairly brief stress episodes is that the offspring have a number of clear changes in terms of how they, for instance, how they themselves react to stress. So they show greatly elevated levels of that stress hormone cortisol that I mentioned earlier, responses to normal challenges in their life that are larger and longer, that take them longer to recover from. So these animals are less resilient to those sorts of challenges. Alongside that comes some obvious changes in temperament. So animals born to mothers that had these 5 stress periods during the pregnancy are seen to be more flighty active in different types of temperament test. So underlying these changes seems to be a change in something that's called DNA methylation. So again, I'm not going to get into the details of that, not least because that's far from being my area of expertise. But really, DNA methylation is a way that individual animals can have altered expression of DNA even when the genes that are being expressed are the same. So for instance, we might have 2 animals, if they had identical DNA but different methylation patterns, they could turn out quite differently in terms of a whole host of aspects of their biology. So what's pretty key and why I'm mentioning that here is that these studies have shown that changes in this DNA methylation pattern have been seen in calves born to these stressed mothers for up to 5 years after they've been born. So i.e. when these calves have been retained and are now part of the breeding herd. And indeed from other species, and there's an example in cattle I'll share with you in a minute, we also know that some changes to DNA methylation patterns can pass on to the next generation. So So the example I've chosen for maternal health, we're sort of moving away from beef production, thinking about the dairy context a bit more. Another maternal challenge that's been the subject of a number of studies is the impact of mastitis on dairy cows. So mastitis, obviously a major cow welfare issue in its own right, also something that causes production drops and economic inefficiencies in dairy production. But we also know that from the perspective of the developing fetal calf, there are some consequences of having a mother that has had a mastitic infection or has general poor levels of udder health across her pregnancy. Calves born to these cows can be smaller and grow less quickly than calves born to cows that have good udder health. And perhaps most pertinently for the dairy industry is the fact that calves kept as replacements may show consequences of this maternal health alteration even when they reach their own lactation. So one recent large US study found lower levels of fat levels, milk fat levels, increased somatic cell counts in daughters born to cows that had poor udder health during their pregnancy. And the final example I'm going to turn to, not something that's perhaps currently greatly affecting stock here in the UK, but which might become more of a concern in the near future, so that's heat stress. So this is a topic that's been really widely researched in a number of hotter countries, particularly in the US, where certain states such as Florida are already seeing a large impact of heat stress related issues in their dairy industry. So the diagram I'm showing here is taken from a recent review of the topic from a researcher in Germany. The text will probably be too small for you to read, and I'm not going to go through every single bullet point here. The difference, this is really a summary of everything that's been known across a large number of research studies in this area in the dairy context. So if we start with the cow in the top left there, a number of documented changes to cow biology as a result of exposure to heat stress, so high combinations of both temperature and relative humidity. So these include changes to, for instance, uterine blood flow, other aspects of debilitated placental function, and more general negative effects in various aspects of the reproductive system. Moving on to B and then C, so we're seeing that the consequence of that, those fetal challenges being transmitted to the calf from the mother, are a whole host of changes in calves born to these heat-stressed mothers. Some relating to production, some clear behavioural abnormalities and alterations, a whole host of physiological changes, and also some compromises to different aspects of immune function, suggesting an increased susceptibility to disease. Where these calves have been tracked through to adults, females that become replacements entering the herd, point C, a lot of those changes have been seen to continue on into animals in adulthood, along with a host of other changes such as decreased milk yield, alterations to milk quality, and so on. Why I've chosen this example is it's one of the really clear examples we have in farm animals where the original challenge to the pregnant animal is having effects not just in the daughter but also in the granddaughters. So this is an example where we're seeing an effect, a challenge being transmitted over multiple generations. So cows whose grandmothers were exposed to heat stress have themselves reduced milk yield when they enter the lactating herd, as well as having lower fat and protein levels in their milk. So we're seeing these sorts of effects that can occur over multiple generations of animals. In most cases, the research studies that are conducted don't follow animals over those multiple generations. So in actual fact, we don't know how common these sort of transgenerational effects are, but at least the example of heat stress in these dairy animals shows us that it's possible that we can have these sort of long-term effects from these original maternal challenges. So I just want to finish up then, I guess come back to the issue of what you might be able to do about this, thinking in terms of your own animal management. So probably many of you will be already thinking closely about nutrition and health in the cattle under your care. Our work suggests there's still a lot of possible improvement, at least on the nutritional side of things, in terms of thinking about managing body condition. But when we think about some of the wider issues that we might put in that more generic heading of stress, there may be some of these other headings in the diagrams here you can see that come to the fore. So I think there might be, these might be examples where you could look at your own management practices and see if there are improvements that could be made to lower cow stress levels, to improve cow welfare. Because one of the key messages of this whole area is that, of course, these things matter for the maternal cow herself. Thinking about the additional consequences that there might be for the subsequent production generation, or those animals becoming replacements and entering the herd with these sort of long-term debilities, I think adds extra sort of emphasis to really thinking very carefully about some of these practices. So are there ways, for instance, that you could reduce feed competition when animals are being fed during winter housing? Could you avoid mixing up different social groups of animals over the winter housing period? So we know that on some farms, when animals are being removed from different pens or groups, for instance, for routine husbandry or for vaccinations or whatever, they may be mixed back into new unfamiliar groups of animals, and that may create some degree of social instability. Again, that could be a stressor. We certainly know in many other species, particularly pigs, that sort of stressful interaction from just social instability can be a really strong driver of these sorts of prenatal effects. Could you, for instance, improve the way staff interact with cows to limit negative interactions? So we know an awful lot about how negative handling of really all livestock species, but particularly cattle, can have this sort of chain of negative consequences, causing increased levels of animal stress, decreased production levels in production animals, but also that it's highly likely that we're seeing these sort of transgenerational, or at least early life effects as a consequence of that handling as well. So of course, in some cases, the answer to this might be no, especially if the changes might require some investment, which of course is difficult in the current costs climate. But at least some of the changes that might be made by having this sort of review of management practices are relatively cheap, or in fact cost-free, and they might pay off in terms of improved welfare, health and performance. Okay, so just to return then to the conclusions, I hope I've managed to demonstrate to you that things that happen to pregnant animals affect their developing offspring, that those effects have impact on progeny biology for the rest of that animal's life, and in fact even possibly for the next generation as well. For farm animals, we see these sorts of changes occurring in a whole host of outcomes that are relevant, the sorts of things that we are really looking to maximize, optimize on our units, whether that's production performance, health, animal welfare, even actually some environmental outcomes that might be optimized by thinking more about these things. And I think there are some opportunities to improve overall farm performance by thinking about how we translate what we know about handling pregnant animals and dealing with pregnant animals, thinking about it in this sort of wider context of the consequences there might be for the generations to come. Okay, so if you want some more information about this area of our work, we have a leaflet that you can access on the SRUC website. We also have a number of different technical notes and other advisory notes on there about body condition scoring. So this is something we're really interested in trying to do some additional work in. I'd really like to hear if anybody has any feedback on that area. It seems like a really easy opportunity to improve management in a way that would have these sort of, I guess, win-win consequences for both the mother and for our developing offspring. I'd just like to finish up by acknowledging some of the funding we've had for this work. The Scottish Government has been a long-term supporter for a lot of our research, including in this area. We've also had some individual research studies from funding from DEFRA and some other funders to work in this area. So I'd just like to thank them for that. And thank you very much for your attention. I look forward to your questions. Thank you very much.
Thanks very much for that, Kenny. So as you send your questions in, I think as chair, I'll ask the first question if I can. So this is really fascinating. But what I'd love to know is when is the calf most at risk of this fetal program? Do we know?
No. So I think, well, the simplest answer would be that we don't really, because there aren't enough studies to identify that. So some of the big things, so the Chondro dystrophy, that was a big epidemiological study that did pin down some key time points in pregnancy that are most, where development can be most sort of knocked off its trajectory. For some of the other things, we don't really know that, because actually it's quite difficult to establish in experimental studies. Probably the answer, what we know from other species, is that it will be different for different types of challenge. So that's that's another way of saying we don't know. But we know, so for instance, some of the social instability stuff we've done in pigs has shown that the middle point of pregnancy is more important than the late point of pregnancy. That's also possible in the case in other species, other mammalian species. So we do know a little bit about placental function in some of these species, and there are enzymes that can be expressed in the placenta that provide a bit of blockage for that transfer of the stress hormones. So there are sort of enzymes that deactivate the stress hormone, and those are in the placenta. So often in some of these species, that level ramps up towards the end of pregnancy. So some of the stress-related things are probably more likely to be in that sort of midpoint or earlier point, particularly because often the changes there are, it's changes to the brain that are being induced. Whereas, of course, we know a bit more about the nutritional side of things, and probably that late pregnancy period is more important for some of these nutritional things. So we know, for instance, body condition score, the advice would already be don't do anything radical in that immediate late pregnancy period, because that's a very sensitive time from a lot of nutritional aspects. But for most things, we don't have the studies, certainly not in cattle, to be able to really pin it down very precisely.
Okay, so more research is needed.
Yeah, I mean that's what researchers always say. I know that's sort of that's always our conclusion. But it's definitely true that probably in of all the livestock species, or even farm species, because actually there's a whole really interesting literature in poultry about this as well. It's and even in fish, actually, it's a sort of thing that occurs across all species. But probably out of pigs and sheep and cattle have been the least researched, apart from some of these really specific examples like heat stress, because for a number of countries, the US and others, that's becoming a really big, important concern, and already is a real problem for the mothers and for the offspring.
That's it. So I've got quite a few questions. What I'll try and do is group them into the different topics. So we'll start with nutrition first. So the first question is somebody who's new to sucklers. The cow in the photo, would you say she's lean or good? So that was the cow on slide 15, I think.
I don't remember what that cow was from thinking about it. I mean, so I would make 2 points about that. I think from memory, I think she's probably on the borderline / lean, but don't hold me to that. The second thing I would
Yeah,
say
she is.
is
Yeah,
that visual condition scoring is not proper condition scoring. So this is one of the things, is probably underlying some of the less than optimal management of condition that's out there. So we did a survey a number of years ago for DEFRA that established that so in the beef industry, about 2/3 of farmers will say that they condition score,
yeah,
but only 4% of beef farmers were manually condition scoring. So when we go to farms, we're manually condition scoring, and I think to do it accurately and reliably and repeatedly, to the point where it's a useful exercise for management, you really need to be getting hands-on.
yeah,
But the hands-on scoring is probably much easier and quicker than maybe people appreciate. When we go to farms, we condition score as cows are coming through for whatever routine handling they're having. So sometimes that can be quick and sometimes it can be slow, but we probably think we can pretty accurately condition score a cow in, certainly less than 10 seconds once you're really good at it. But you need to get hands-on because that visual, it's just not an accurate way of doing it. That's
yeah.
hedging my bets whether I'm wrong about that cow, I guess.
She did look quite lean from
Yeah,
that.
it's really, when you look at the sort of relationship between visual and manual, it's really difficult, particularly once you go across breeds and, heifers versus older cows. There's all sorts
Yeah,
of things that make it difficult to just look at cows and do that accurately, even if for management purposes you don't need to go as accurate as we would for research purposes. But I still think there's a lot of I guess from somebody visiting farms, there's a lot of people who are just eyeballing the cows, and
that's it.
some get it right and some get it wrong. But
Yeah,
it seems like a real easy opportunity to, start to optimize management.
yeah,
So we're really trying to push it to get actually the, greater uptake of people getting hands-on and actually, doing that scoring that way.
yeah. Brilliant. So the next question is in relation to this. So after the dry summer, their herd is leaner than normal years. Hopefully the good autumn grass growth and good winter silage to be fed will up the dam's condition to good. Is there a difference in which trimester that the stress occurs? My herd calves in February and March.
So in terms of the stress of being lean.
Yeah, so that occurred in summer, whereas the hopefully getting back into condition with the autumn grass growth. So do you think
Yes,
had an impact?
I guess again, even the work we did didn't, was the data's too messy for us to pin that down particularly well. In some respects, I would say, well, actually, all you can do is deal with the hand that you've been dealt. That's not a very
Yeah,
satisfying or very scientific
yeah,
answer, but I think what we've done is demonstrate that it will always pay off to try and mitigate that when it's happened for whatever reasons. And obviously, that what people are seeing when cows are coming in the autumn can vary for a number of different reasons.
mm,
Often those which are entirely, they're often about grass growth and weather and, things that are not within people's control. I think the message is when those cows do come under your control, it's really important to then, it will pay off to try and do something about that.
that's
And sometimes, a lot of those farms that we were visiting, for instance, would have capability to score and then have different groups of cows, cows that are grouped by condition score, so that it's a more targeted response to that. So yeah, I don't think I can answer the question directly in terms of sort of trimesters, but in a way, there's nothing you can do about that. You just have to try and mitigate it, and do whatever is possible to bring those cows
Yeah.
round to the optimal zone in, well, for them, sort of post Christmas, New Year, for calving in February.
Yeah, that's it, because it can also affect conception for the next bulling period as well, can't it, if they're under condition?
Yeah, I mean, absolutely. I mean, that, and the data about that's been around for a long time, is probably pretty well known. And, like I was saying, I mean, the sort of economic stuff we've done doesn't even touch on that, actually. So and that's, but that's a big aspect of the economics of the whole thing, is, the fertility issues that are out there, and extracting, on a sort of farm level, or even on a national level, having more calves from the number of cows that we already have. We already see that the cow herd is falling, and people are, obviously the situation is getting slightly better because the calving, that I think things are improving, but there's there's still a gap there. Definitely.
So the next question on nutrition is there any research on fat cows and their effects on the calf and pregnancy?
So, I mean, we in the data, we have, you saw the sort of distribution. There's, in that study, there was a large number of quite fat cows. It's really interesting, because so the classic sort of information that's out there is avoiding these fat cows because of the risk of calving difficulty. Actually, Rachel Bragg's study from the vet school here didn't really find that was a big risk. And when you talk to individual producers, often they say, they can manage it in their context without too many issues. I think what we've found is, there's so few cows that are fat and stay fat, that really you're always looking at those ones that are going from fat to good, which is, the recommended pathway for these cows. That's sort of what's put forward as the, and that's, that's the sort of evolutionary history of cows, that they put on condition over the summer and then lose it over the winter, and that's sort of deemed to be normal. Probably what we found is that the one risk there is if that condition change is too rapid or too extreme. So probably, for really fat cows, they can be managed downwards, but moving a cow from, if a cow's coming in at 4.5, you probably don't want to be looking at 2.5 as your lower target. That's too extreme. It's too much loss. So it's about, I think it's more about the change than about the absolute condition in a lot of the data.
Okay, thanks, Kenny. So I think that's all the nutrition questions out the way. So we'll move on to stress. So there's a question here. I'm due to move farm next year. My cows are quiet and well handled. Is it best if I transport them when they've calved? They will be transported individually in a livestock trailer by ourselves.
On the whole, I would say yes. I mean, obviously there might be some issues about, the age of the calf and things like that for the transportation. Equally, I would say, I wouldn't be too concerned about a single transportation event. It will be a stress. When we think about stress, there always will be things that are stressful that occur. We can never achieve a sort of entirely stress-free existence for animals, and there's a lot to suggest that that's also not necessarily a very healthy state of affairs. There's a lot of the sort of work that's out there that suggests actually it's about having animals that are in a sort of optimal middle zone. So I wouldn't be particularly too concerned about a single transportation event. Probably, you want to avoid early pregnancy just for, for keeping the calf and all the pregnancy. But I don't think it would be a major concern as a one-off event.
Yeah, because I read a research paper and it said that most like losses of calf, it occurs in the first 42 days, isn't it? Yeah, before the egg's implanted, which, yeah, it's really interesting. So another question on stress. Let me see, we'll go with this one. So heat stress. Would this year's high temperatures be high enough and for long enough to cause problems like cows now scanning at knotting calf that we're seeing bulling earlier on in the spring?
Yes, I think it's entirely possible, given what we experience, and particularly given, so one of the issues here is the extent to which animals are adapted. So it's a lot of the information that's out there would, suggest actually it's not about absolute levels. I mean, it will be at extreme levels, but actually it's also about what those animals are used to. Also, what's really important, which is particularly why it's places like Florida and other regions where there's both high temperature and high humidity. I mean, we sort of know that generally. We talk about heat stress, but actually what we mean is that combination of both high temperature and high humidity. So I don't think that's quite so much of a concern for us here, even with the sort of periods that we went through over the summer, in terms of cows, or other livestock struggling to cope. But equally, it was a a stressful event for many humans trying to get through that period. So it's entirely possible. Again, whether that would be enough to cause sort of fertility concerns, I don't know. But
do you think it's likely it might not cause issues with fertility, but do you think it cause changes in behaviour? Like, do you think that the cow is less likely to show bulling, or the bull maybe just can't be bothered in the heat?
Yeah, I guess so. I mean, it seems entirely possible. I mean, it's one of the I think with the whole area of heat stress, or even cold stress, one of the issues we have is we don't really very well understand the cow, or well, any species, but cows for tonight, their perspective on it. So our understanding of the sort of thermoneutral zone for these animals is based on it's viewing them as sort of machines, that they're just they're physiological processes. We don't really understand, whether the limits of what they find pleasant or unpleasant are in relation to those physiological processes. So actually I think that's the other side of it, is it's another area that we, it's the same cliche, we probably need a bit more research in terms of actually understanding the cow's perception of things. Because when we start to talk about these stressful, stress as an issue, some things are by definition, inevitably stressful for animals or for humans, but a lot of the other aspects of it is about the animal's perception of its situation. So stress can occur even when there's no active threat. If animals are very fearful or hyper vigilant or whatever, even if there's not really a threat, they can still be stressed. And vice versa. Actually, if the animal has a perception that what's happening is within their tolerable range, that's probably what matters, not the literal figures. But yeah, I mean the behavior, yeah, because there will be behavioral changes, and that could mask other other aspects of the cow's life.
Now, and the final question on stress is, do you think the breed will alter the susceptibility to stress during pregnancy?
So I think the simple answer to that is probably yes, but we don't have a very systematic, I'm not going to sort of, list problematic breeds or not. We know some breeds are more flighty and temperamental than others. One of the really interesting things, and I just briefly mentioned it within the talk, is there is a sort of, across a number of species and a number of studies, this suggestion that highly selected animals are actually more susceptible to these sorts of early life deviations to development. So it's sort of like, you know, if you have a Formula One car, when the Formula One car goes off the road, it's a bigger problem than if, you know, my Skoda goes off the road. And I think it, you know, that there's less margin for error in a lot of these very highly selected breeds. So, you know, breeds that are more selected for, you know, high production levels or whatever it is, you know, seem to be less able to buffer, you know, the link between the mother and the offspring is less buffered than it may be in, you know, less highly selected animals. So it's another example where actually, you know, we would be telling, you know, beef producers, I mean, dairy producers are already all over genetic merit and, you know, all of those aspects. Beef a little less so. But for those where that is you're actively thinking about it, a lot of this is about the fact that the animal that you get, your production animal, your replacement, is not just entirely an outcome of its genetics, it's an outcome of all this other stuff. And yeah, I'm sure, you know, breed effects will be present, and probably it's mostly, you know, if we take a continuum from, you know, animals that are living, you know, closer to a natural cattle life and are much less highly selected compared to the highly selected end of the breed spectrum, you might expect more issues there.
Okay, thank you. So the last questions are just to do with health. So the first question, are the impacts of mastitis during pregnancy the same in beef cows as dairy cows?
So it's a good question. I don't think it's something that anybody has ever really looked at. I mean, actually, you know, I'm trying to think whether there was a Swedish, sorry, I'm trying to remember. There was a Swedish study, and I'm wondering whether that was in beef cows. I can't remember off the top of my head. I mean, there's no reason to think why it fundamentally wouldn't be. I mean, mastitis is just a fairly, well, variable, but something that we would believe is just a clear negative event from a welfare point of view, associated with pain and all the rest of it. You know, much less thought about in beef cattle. I guess, you know, you have the issue of a suckling calf versus not having a suckling calf. But on a biological basis, there's no reason to think that effect wouldn't be pretty similar. You know, it's probably not the specifics of it being mastitis, it's the issue of it being painful, causing an inflammatory state, you know, debilitating the mother, you know, because there are other health related issues that have shown similar effects, such as parasitism. So, you know, and even foot health in other species, so lameness and things like that, you know, I didn't mention, even though there are huge issues in cattle, because there aren't specific cattle studies, but there's some really nice sheep studies looking at, you know, benefits of dealing with foot health problems in pregnant animals from the perspective of their offspring, and some, you know, really nice economic modelling in sheep from Warwick about the benefits of dealing with that. And I think that's, you know, that's part of that. It's just an example where anything that's debilitating to the mother, painful and so on, you know, can have these effects.
Yeah, thank you. So the final question is on TB testing. So has any studies been done that show the current TB testing regime when applied to pregnant cows is harmful? And how can these risks be reduced? Is there a best time for TB pregnant cows?
So I think the simplest answer is that no, we don't know. I mean, even, you know, if we took it more broadly, just about handling cows and frequency of handling or nature of handling, you know, that those studies just don't exist. We can sort of predict from first principles that, you know, because if you go to a whole load of farms, you will see a vast array of different handling facilities of different quality and different, you know, age and all the rest of it, and also interacting with the, you know, I mentioned it, the behavior of people using those facilities. So there's a huge range there, and I guess it would be like for, you know, for any handling event, it will pay off to, you know, to have that as being as stress-free as possible. It pays off for the cows, it pays off for the people, and probably based on what we know from first principles, at least about this whole area, it will pay off for the progeny as well. But, you know, the specifics of, you know, thinking about TB testing or any other event where there's handling, you know, we just don't know the specifics of it at all. So it's a general, you know, try and do it in as you know, stress-free a manner as possible. That's good for, you know, multiple reasons.
That's it. Okay, Kenny, I think that's all the questions. So it's just my job then to bring the webinar to a close. So I'd firstly like to thank Kenny so much for presenting to us tonight. It was a really fascinating talk, and I think this is quite a new area of research, and obviously there's still work to be done, but it obviously shows ways that we can try and prevent it. I'd also like to thank my colleague Bryony, who has been working behind the scenes to ensure that we didn't have any technical glitches tonight. So thank you ever so much for that. And finally, a big thank you to everyone who has been listening. I really hope you've enjoyed the discussion tonight. When the webinar ends, you will be taken to a survey. So please, if you can, provide us with your feedback. It really helps us tailor these webinars to your needs. So thanks again and enjoy the rest of your evening.